It's also called inverse, arc sine, arc cosine, arc secant. Those are all the inverse names. The book and homework use a different notation because writing the word arc takes up more space when you're printing, apparently. But it's whatever. So chapter 8.1 is inverse trigonometric functions. Okay. And so let's talk about inverses in general. I'm sure it's been a while since you messed with them. First, let's look at the notation. So F inverse is usually denoted with a -1. Oops, there's somebody waiting to be let in. F inverse of F. So if you have the inverse and its original function, they will undo each other and leave you with just x. This will work for every x in the domain of F. So for every x in the domain of F. So whatever's inside here is what we're talking about. See what I mean? So which axis can I use? You may see this composition. It has to be the one that's inside. And that'll be important later. If you write it the other way, F of F inverse, you still get x, but the restriction of the x's you can use is for the one in here now. For every x in the domain of F inverse. Okay. Let me write down the definitions. So do you remember when we talked about the domain and ranges of what's it called? Of different types of functions, right? So for a function to have an inverse, it has to have a one-to-one domain. There needs to be a function and it needs to be one-to-one. And this is what I'm saying. Let me show you a picture. Okay. So this guy is a function, right? We talk about it all the time, x squared. Because if we draw vertical lines through it, right, we said it's going to hit only one time, which means it's a function. But if you draw lines horizontally, I hit it twice. That's how you check for one-to-one back in college algebra, right? Now we do know that there is an inverse for x squared, right? That is the square root function, right? Because if you square root an x squared, they undo each other and you're left with just x. So those are technically inverses. So these are inverses, but you have to restrict the original. So if we were to cut off, let's say I don't look at anything to the left, right? Just from here to here. So 0 to infinity. This function has an inverse that does this. So you have to restrict the parabola in order to define an inverse function. So that's going to be the same deal with our trig function. So if you look at it, y equals sine x, we know that's a function, but since it keeps repeating, we lose that one-to-one stuff, right? But if we restrict it from here to here, and we cut everything else off, Then we can define an inverse. Let me show you a better picture in the book here, or the notes I sent you today. There we go. This is the idea. You guys see the PDF link? Okay, so to define inverse, we have to restrict it to force it to be one-to-one. So if we cut sine between here and here, then we can create an inverse. So we will define the inverse function like this. This is from your book. We'll write it down in a second. So we can't define it until we do that. So this guy right here, move in. So here, the blue one is the red one over here. Here it's restricted, so then we're able to define the blue guy here as the inverse. But we cannot do this until it's cut in that section. Okay. All right, so let's write down the definition. Okay. So that's the idea. I don't want to have force you to draw all this stuff. I just want you to think about that. So this is why it's defined this way. So the inverse function of, well, let's say inverse sine function, it sounds better. Inverse sine function, y is equal to, so they write it this way, sine inverse of x. So y is equal to sine inverse of x if and only if x is equal to sine y. So in logic and math, if and only if is an important statement. That means it is true in both directions. So it's a double implication. So if this is true, then that's true. If this is true, then that's true. So you can go backwards and forwards. Just for information. Also, if and only if, in math, we usually just write IFF. From now on, that's what I'm going to write safe space. So the domain, so if and only if is the definition where the x values are defined between -1 and 1, and the y values, the range, right, will be between pi over 2 and -pi over 2 and pi over 2. So that's for sine. Now let's write down the cosine. I'm going to write a note here, also written like this, arc sine x. Some people prefer that because if you write it this way, sine inverse, the -1 looks like a power, which is confusing. So if you want to write it this way, that's fine, because you can square this, right? But if you square this, you need to remember that's just a notation, not a power. But anyway, it doesn't matter to me. It's just up to you. But the book and the homework are going to use this. Inverse cosine function. We'll write the arc cosine. So y is equal to cosine inverse of x if and only if x is equal to cosine y. this will have a similar domain, but not the range. Y is between 0 and pi. Okay, inverse tangent. Also written as arc tan of x. So y is equal to tangent inverse of x if and only if x is equal to tangent of y. This guy has a domain everywhere. There's no restriction in the domain. So negative infinity, oops, on the side you can see, it can't be equal to infinity. And y is between negative pi over 2 to pi over 2. So when you make a formula sheet for test 2, I guess, you're going to need all this information. Okay. Here are and you're going to need the following. The following properties are very. So properties of inverse functions. So the first one, now all in one place. F inverse of f of x. That would look like for sine, right? If you have sine inverse outside and the regular sine inside, we said that if you compose an inverse with its function with its inverse, right, then you'll get x. But for which axis is this allowed, right? And that's when you have to look back at what is the domain, what is the range, etc. But if you don't want to think too hard, then you should write this here. It would only cancel. It will only be defined where x is between negative pi over 2 to pi over 2. Okay, number 2. If you switch the order and you say, you know what, I want to do f of f inverse, then this will only work. This will only cancel to give me x, where x is between negative 1 and 1. So you're going to have homework questions where they put some number in here, and you're like, okay, that means I just write the number, right? Like, for example, if this was 0, sine inverse of 0 should just give me 0 because of the cancellation, right? This argument, whatever's in there, should come out. So that only happens when x is between here. So pay attention to what is the x value before you choose an answer. Now let's write down the cosine rules. Number 3, so f inverse of f. So if you have the cosine inverse outside, that should cancel to give you an x if your x is between 0 to pi. Now if we switch the order, f of f inverse. That would be cosine of cosine inverse. That would give me x.
Can you slide it up a little bit?
Yeah. Where f of f inverse, let me think. Yeah, -1 to 1. I don't expect you to memorize all these, but I would have these handy so I don't have to worry about it. So that's what I would do. Because I know in general, right? Because you see how we wrote the big picture idea up here. So we know which x's are allowed. We just have to look at what is the function inside. So if the one inside is sine, then I need to know what is the domain for this guy, right? Once it's restricted. So it would be this. But if you don't want to, if you want to just write these rules down, that way you can check yourself, you'll be fine. That's okay. The cosine. Okay, now let's do tangent. F inverse of f would give me tangent inverse of tangent. So cancel to give me x, where x is between negative pi over 2 to pi over 2. And the last one, so let's put the f inside. So tangent of tangent inverse should cancel to give me an x, as long as that x, actually it could be anything on this one. So if the tangent's out, if the inverse tangent's inside, it will always work. Dang it, that's what equal to again. Infinity is not a value. You can't be equal to infinity.
So for number 1, can x be equal to negative pi over 2 as well?
Yeah. Yes, it should be. You just can't go below that. So if you go below, then you would say undefined or something, then move on. All right, so those are all the properties we need. We should be able to start doing some questions. Do you have any questions on the definitions or the properties or the big picture concept? Okay. All right. Let's do an example then. So you can use your calculator or a unit circle. Not a big deal. But you need to understand the concept. For example, let's say we're doing sine inverse of the number 1. What exactly does that mean? So we go back to the original, right? The original sine function receives angles and then outputs values, right? Like sine of 90 degrees, sine of 0, whatever. Then it outputs a value. Sine inverse does the opposite because it's an inverse. It takes a value and then spits out an angle. Okay, so let's make it more interesting. Let's say it's negative. So the question becomes, which angle gives me -1? If we write the definition, remember we said if and only if, right? It might help you understand a little bit better. This is true, that's true, right? So let's use that definition to help us out. So another way to write this, this is the same as saying sine of some angle is equal to -1. What is that angle? Yeah, that's what that's what this does. So look at the unit circle, in case you don't have it memorized. You should look at it.
Negative 90.
Yeah, maybe -90. And we choose -90 because that is within the definition, right? We have to go the negative direction for the domain values, the range values, sorry. Where's that circle? Here we go. So let's try to bring it home here. Sine inverse is defined between pi over 2 up top all the way down to negative pi over 2. So I got to go this direction, right? With it from here to here. I never go past this point. I have to go negative. I'm not allowed over here. Although if the angle does exist over there, you have to find a coterminal angle. But anyway, sine is -1 at 3 pi over 2, but since that's not in the domain, you'd use -90 or negative pi over 2. Okay. Does that idea make sense? The cosine inverse of -1, right? You have to remember where it is defined. That's the same thing as saying what angle gives me -1. And cosine is defined on the top of the circle. So let's go back to the circle. Cosine inverse is only defined from 0 to pi. So it's only on the top. So -1 happens at pi, right? So value that gives me -1 is pi. Does that make sense right here? This x value, right? And the cosine refers to the x value. So which x value, I'm sorry, which angle gives me that value? That's what inverse means. Okay. Do one more simple one here before we get to the composition. Sine inverse of square root 2 over 2. That would be pi over 4, right? 45 degrees. Does have any questions on these first three? And just remember, this is by definition, I can rewrite this as this. Okay. And this is the theta. All right, so move on to something else. This is when the domain starts to matter. Sine inverse of sine of 0. Does that equal 0? Or is it out this 0 outside the domain? You look at this value, you figure out, okay, what am I allowed to use? We'll go back to those 6 properties we wrote down. If sine inverse is outside, then the x in here, which we have 0 currently, right? That better be between here and here. 0 is between negative pi over 2 to pi over 2. So we're good. So the answer would just be x. So our x is 0. About this one, cosine inverse of 1.2. Is that equal to 1.2? Maybe, right? Let's see. If cosine's in the outside, then it will be equal to x if I'm between -1 and 1, but 1.2 is too big, right? Do you see how it works? Then this is not defined. If you try to do this in your calculator, you'll get an error. So if you do this, right, let's try it out just for fun. If I were to do sine inverse, use sine inverse right there, of sine 0, I should get 0 because it's in the definition. So if I do cosine of cosine inverse of 1.2, I should get an error because it's not in the domain. So you can also try it on your machine and figure out. You can see right away it's not going to happen. Anyway. That makes sense. Okay. Let's move on to something else. You guys remember in college algebra, they'd give you a function and they'd ask you find the inverse function. That's like a couple of steps a while ago. So let's go ahead and try to find an inverse function using the exact same steps from college algebra, except we have to deal with the inverse trig instead. I'm going to write down all the steps in case you forgot. So find the inverse function, which we're going to call f inverse of the function f. Find the domain and range of f inverse. All right, so let's do a couple of examples. We'll call this part A, I guess. So f of x is equal to 4 sine x plus 3. They want me to find the inverse function. Okay. All right, so step 1. Change f of x into y, or replace it, in other words. So we're going to do this. Y equals 4 sine x plus 3. Step 2. Step 2. Swap all x's and y. So you'll get x equals to 4 sine y. Right? Okay. Step 3. Solve for y. In order to solve for y, we need to isolate sine y and then cancel out that sign. The only way to undo sine is to introduce the sine inverse. Kind of like when you did log equations, remember? You have to introduce e or introduce ln to cancel e. same kind of deal. So I'm introducing sine inverse to cancel sine. So here we go. So subtract the 3 over, divide by 4, and then get to here, right? So at this point, you will just sine inverse both sides. So you'll end up with sine inverse of x minus 3 over 4 equal to sine inverse of sine y. So this cancels the signs. So sine inverse of x minus 3 over 4 is equal to y. So the answer would be f inverse of x is equal to x minus 3, oops, that's just the sign thing. Sine inverse of x minus 3 over 4. So that would be your inverse function. Now, what is the restriction for sine inverse for the domain? Because we found the function, but the question did say find the domain range too.
Greater than negative pi over 2 and less than pi over 2.
Yeah, that would be the range. That's not too bad. What is domain though for the original sine inverse?
Negative 4 to 4.
No, for the original, you just regular sine inverse. Okay, so we know, let's look at it real quick. Looking at the definition, we know it should be between here and here, right? But since we have that 4 and we have that divided by 3 or whatever, we're gonna have to adjust. So our x in here is not the same x. So I'm gonna do it over here. Find the domain. So we know that the original f inverse sine is between here, right? So we just check. But our x is actually x minus 3 over 4, right? So we solve this one here in order to find the new domain, the adjusted or transformed here domain. So you multiply by 4 on all 3 sides, and then you would add 3, which would get us to here. So the actual domain would be this. So inverse function, just put it all together, is this answer. And the domain of this will be brackets -1 to 7. Range will still be the same. Does that make sense what we did there? Because we knew the original, so we just solved for the new one. Right? I skipped some algebra steps here. If you missed something, let me know. I just wanted to see how you set it up.
So how did you get is that a 7?
Yes.
Oh, so how did you get that 7?
So
Is
first,
it 4 and -3?
Yeah, the first step we did 4 times 4 times 4, right? That part made sense. You cancel the 4 down here. 1 times 4, negative 1 times 4 gets you here. Next step is you do plus 3. So 4 plus 3 is 7. This plus 3 cancels it. You do the next. Negative 4 plus 3 gets you here.
Okay.
So that's why you solve inequalities that have 3 steps.
Okay.
But then once you have that, that is the domain of the function you found. So this is our answers here. So all this ideas are technically from college algebra. We're just applying it to the trig inverse. But if you forgot something, just let me know. It's not a big deal. Or if the step seems weird, we can talk about it some more. And we'll do a couple more of these too. Okay. So one more example and we'll take a break. Oops. Forgot to erase all this. Just remind myself not to scan them. All right. Next example. So it's going to be the same stuff. Find F inverse and the domain and range. Of F inverse. Okay. So here's the function they're going to give you. Let's take a good one. Negative 5 cosine of 4x. So we know that this original has a domain. What would be the domain of original cosine when we first started the class? You can plug in whatever the heck you want, right? And then it would always output between negative 1 to 1, right? That's just the original. So don't forget. Anyway, so step 1, we said change the y. Change f of x into y. So y equals negative 5 cosine of 4x. Step 2, swap y's and x's. So x is equal to negative 5 cosine of 4y. Step 3, solve for y. Okay. So here we go. Let's divide out the negative 5 as the first step, right? It's the only thing in my way. So you would get x over, what would become negative, right? When you divide by negative 5. Good thing a small step there. Let me know if you don't see it. So then at this point, you do cosine inverse of both sides. So that would give us cosine inverse of negative x over 5 equal to 4y. Okay. Then divided by 4, so we get 1/4 negative x over 5 equal to a y. Okay.
Can you go up really quick?
That's it.
Up. Okay, I got it.
All right.
Thank you.
Cool. So far, these steps are making sense.
Yeah.
Okay, so I'm skipping that minor algebra stuff here and there, so I'm hoping that's okay. All right, we divide by 4 both sides, right? That's where the 1/4 comes from. I divide by -5 both sides. That's where this came from. This cancels. Then we have our f inverse, right? So this implies that f inverse of x is equal to 1/4 cosine inverse of negative x over 5. Okay. So the same deal here. You need to remember what is the domain for cosine inverse. Right? Looking at our notes. It should be -1 to 1, right? Should be. So to find domain, be a little more proper here. Take the argument negative x over 5 and restrict it to the domain of cosine inverse. That's what we did before. I'm just putting it in words this time. So it's -1 to 1, and then we solve for x. Multiply both sides by -5. That would give us just this. Check everything.
Is the 5 on the right supposed to be negative?
Yes.
So did you change the signs because of the negative x over 5?
So we multiply on both sides by -5.
Right, okay.
So let me double check something before I commit to this. I just don't trust myself at the moment. It feels like there's something missing. Let me just graph this guy. Double check that this is true. Negative x over the domain is off. Yeah. No, we don't switch those guys. It should stay. Like this. There. I was trying to decide if I should flip these or not. Everything else is fine. So domain will be -5 to 5, because you always put the smaller one first. And of course, the inverse we wrote up there will be this guy. Okay. Do you have any questions on this example before we take a break?
And then the range would be the, what is the, does this one have a range?
Yeah, the range will be, let me see. Well, the original, what is the original range supposed to be?
-1. Is that it?
If you look at the notes right at the beginning, we said the original cosine is 0 to pi. So it should be 0 to pi, but that 1/4 messes it up. So to make it easy, you should just graph this guy. But technically you would divide by 1/4 because of the amplitude. So let me show you the picture. It's 0 to pi over 4, yeah. Put the range down here, I guess. It's supposed to be 0 to pi, but the 1/4 changes. And divides the range by 4. This is the picture. See how the original, our cosine, would be here. Well, let's put a negative there. So there's the original, right? 0 to pi. That's what the note says in the book. But the 1/4 makes it go from 0 to pi/4. So that coefficient in front will change your range. But I would recommend graphing it and double checking yourself. That way you won't miss anything. If you do it analytically, you would use this approach to find the domain. But you could graph it and look at it, right? The domain's right here too. It's -5 to 5, right? It's right there. So technically, it's right here. So you can check your answer this way too. All right, that's the ending of 8.1. Do you have any questions about this so far? Any other questions? All right, let's take a, yeah. Oh, that hurt somebody. Okay, so we'll stop here. Come back at 7, let's say 7:20. The 15-minute break. Okay, you said 720, right? I can't remember.
Yes.
Yeah, you did.
Okay. That was then on 8.2. So 8.2 is just a continuation of inverse functions. It's really just one section, a long section. Inverse functions continue. Right. So these are the type of questions you're going to see on the homework. You're going to say, find the exact value of cosine of sine inverse of square root 2, oops, sorry, that's too small. Let's see. Square root 3 over 2. So notice how they don't match anymore, so they're not going to cancel like before. So what you have to do is use the definition and the triangles to help you out. So let's write this again. Cosine of sine inverse is square root 3 over 2. So what you do is just to make it simple, let theta equal to sine inverse of square root 3 over 2. So that's the angle inside, right? From theta. So remember, this implies by the definition that there exists an angle that will give me this value. So then just use your triangle to solve this. So this right here is the definition. Right? And then using the idea that sine theta is equal to opposite over hypotenuse, you can bring it all together and solve for cosine. This is what they're really asking is, what is cosine given this information? When you see this question, this first question here, the way I want you to think about it, because I know right now it seems like there's a lot going on, but if you sum it all up, it's saying, given this idea, this information inside the cosine, what is cosine? So you use a triangle to solve it. So we have sine theta defined as this, because that's what the inverse implies. So we have opposite over adjacent, right? Sorry, over hypotenuse. Solve for the adjacent side, and I'm going to skip the Pythagorean. It's going to be 1. So use this to find cosine. And so the answer would just simply be that value. So cosine inverse, cosine of sine inverse is equal to 1/2. 1 over adjacent over hypotenuse. You see how that works?
Can you use the circle chart thing for that?
I'm going to say probably, but eventually it will not be numbers. It
Okay.
could be a general U. So don't stay away from this idea.
Alrighty.
Yeah, I think you might be right. We could say, well, if this is sine, what would be the cosine? But yeah, that might work sometimes. But I do want you to remember, because this is forcing you to use the definition of inverse, and then it forces you to use the definition of opposite over hypotenuse for triangles. So it's bringing in multiple sections all from test 1, all at the same time. So using all those ideas, you can find cosine, which is good practice for test 1, right? And for reviewing our stuff. Let's do another one though, because I know the first one right now sure feels weird at the moment. So tangent of cosine inverse of 1/2, right? So you look at the inside, and we remember the definition means that there's some angle exists that will give me a half. So then build your triangle based off this idea, right? Solve for the opposite side, and then you can find tangent. So tangent of theta is equal to opposite over adjacent. So opposites over adjacent. So all you have to say is, given this information, the tangent will be root 3. This will be your answer. Okay. Now let's do one where it's not numbers, so you can see why you have to do it this way sometimes. Do you have any questions on 1 or 2? Okay. Number 3. Write the trig expression as an algebraic expression in terms of u. Okay. So here's cosecant of cosine inverse of u. So now it's not our number, so the circle is not helpful at all, right? So look at the inside, remember that cosine inverse of u will give me some theta, right? This implies that there is a theta inside cosine that will give me the u. And then the triangle based on that theta would be adjacent over hypotenuse, right? Solving for the opposite side in general would be 1 minus u squared. So that means that we can solve cosecant of cosine by looking for what is cosecant defined as in terms of this triangle. And cosecant is what? 1 over sine root. So it would be 1 over opposite. Yeah. Offense over opposite. This guy. If you rationalize, you get this. Any steps here that are strange or don't make sense. I think that's pretty much it for 8.2 is basically just what do you do when you have cosine inverse of sine or cosine of tangent inverse, those combinations. And then what do you do when it's general, some variable u or x or whatever. You see where that one came from? Right, because u can always be written over 1. Right? So u over 1, and then you do your Pythagorean to find this guy. All right, well, we'll stop here. You guys have any questions for test about exam 1 or any topics you're concerned about?
So what is it that we are able to use during the test? I know you had mentioned a sheet of notes.
Yeah, you can use your unit circle. Scientific or graphing calculator is fine. You can make a page of notes for all those properties, etc. Front and back is fine. But that should be enough.
Sorry, have you posted the video from Monday doing the review?
I think I did. Was it not up?
I didn't see it.
Okay, I'll check after class then.
Professor.
Yeah.
So the review will be due today, right? Or is? Or
I think they review. I don't think it has a due date, but let me double check.
Oh yeah, in the top it says not the date.
Yeah.
Inside of it, though, I think in the text it said September 23rd.
Oh,
Yeah,
That was old.
confusion.
yeah. I deleted the. Originally there was a due date, but I removed it. I just didn't realize there was still text in there. It says 27th. Like right now, Sunday 27th. But basically, just make sure you've done the review before your exam is due. And if you do that, I may do some extra credit stuff, and of course, it's going to help you because it's good practice. Doing it after the test is kind of pointless.
Okay. So the exam will be open until the 28th, you said, right?
Let me check. At least exam 1 is due. Yeah, it's open till the 20. Test 1, 27th at midnight, which is Sunday night.
Sunday night. Okay.
So make sure you start the test. If you're gonna do it on Sunday, make sure you start it at at least 9 p.m.
Okay.
Give you some time because I think it's about 2 hours long. So if you start at 11, you'll get kicked out after an hour. And then you have and then upload your work right after you're finished using a scanner or whatever app you choose.
Okay. Okay.